What's up, everybody? Ran to Pittsburgh, visit some friends, do some work at their house. Didn't have a contract right now at home, so we came here. Anyway, my buddy, good friend of mine, actually started TMFX together. Since then, he's moved back to Pittsburgh here. But he bought this old home, built, I want to say, middle of the 1800s, about the same age as my parents' house, maybe a little newer. These are all sawn joists and stuff, which is kind of nice. The house I grew up in, there were areas where the joists had bark and stuff on them, so a bit older than this. Anyway, they've got this laundry room. There's several things that they wanted to look at addressing, but this house was sort of flipped. It's got some new tech and stuff all over in here, all this, you know, PVC and PEX. You know, to begin with, this area was constructed on an I-beam. You know what, and this is a couple years newer than the fundamental earliest, you know, first parts of the home. Still sawn. Let's see if I can turn my light on. Still sawn joists. Anyway, this is the original sewage stack, vent stack, and it's cast iron to this point. Then it's a Fernco to Fernco onto the flange end of a cast iron. Somebody must have thought that was legit. I guess maybe in the flow direction. Anyway, this is ABS plastic, and the floor is poured around that. So I'm under the impression that, you know, from here on through the floor and out to daylight, or excuse me, to the sewer system here, that it's nice and clear, smooth plastic. And so what somebody did was leave what's here for a cast iron for somebody to replace later if they so choose, if they get in more involved where all that mastic and shit is packed up. Anyway, he's got a 3-inch toilet and sink and shower comes together before this, and then comes over, rolls over, and joins that. But in the again, in the laundry room area, someone, to start with, this kitchen sink was added. It's in the middle of the room here because it's in the kitchen island. But instead of going over to the stack, they went entirely in the other direction, below the plane of the ceiling, Janktron 9000, over and over and over to this copper, which goes over into the wall again for some reason, keeps dropping, then goes into HDPE water line, flexible, and that goes, the black stuff, to the white underneath the PEX there, to the black again, and into the wall. And anyway, it's constantly wet here whenever the washing machine kicks wastewater into that whole system too. And then the only vent it's got is one of these hokey, like Schrader valves. And this here looks just like garbage. This is like, it's really awesome to move something like this house, update it and put in PEX, but not with just random ass fakakta stuff routed like a jackass with nothing holding it down and stuff. This isn't anything that my buddy did. This looks a little bit nicer here. Still questionable at best. We're going to just entirely replace this, basically. Washing machine's going to move over here. So is the slop sink. So we're going to have slop sink, washing machine, dryer. And so to begin with, I popped the gas line to the dryer. It was just sort of in like a Molly type, you know, wall locker or whatever for the concrete. This is an old, maybe the sump pump or something. Sump goes out here now. I don't know why it's so high. I'm just trying not to dig deeper than we want to go as far as scope. So I'm just going to leave this stub out here, but I want to put a plywood slab on the wall so that all the hold downs for all of the drain and water supply systems that we're going to install here. See, they had a bit of one on the wall over here, but because of the center line of the drain in the floor and stuff, oh, this all leaks over here too. And it's just a mess. We're gonna fix it. We're gonna fix it all up. How about you just stay shut? How's that? Okay, bud. So then we got this whack block. You know, we got to be, you know, more than 4 inches over. Anyway, we're gonna just do something like that. We'll use a full sheet. We'll go behind all the equipment, and we're going to basically grab the sink and then the washer and go along here, and then the kitchen sink's going to come over in the wall bay and jog over and fall into that line. And then the last thing here through the door, we're going to take this end off of this 3-inch here, and he'll just roll down the wall and straight fall into that line and just continue to go downhill. And then we'll install a Y here at the bottom, and we'll replace from him all the way up. We'll smash all this off, smash all that off, smash this out, smash it out to here, put a Fernco there, and this is ABS so we can socket weld the bottom of our new PVC Y and PVC between. And then this can be taken that way in the next few days. I'm going to split my time between some different friends' houses right now, but if they want, we got to go over in there where it's just a crawl space out there underneath that bathroom, and that's why the water supply to the toilet freezes periodically. But I'm going to crawl over in there from another area of the house, and then we'll see how big of a pain in the ass it'll be to keep going with plastic all the way over to that bathroom also, which is that's a best practice. So first order of business, we're going to get this hole. I just plotted out the elevation of the center line of that stub thing and how much further from the center line of it over I wanted plywood, because I just got to hit my water supply shut off and my P-trap support onto that plywood underneath the sink. I haven't got to go much farther than that. It'll just look nicer if there's plywood completely behind the sink. Again, trying to avoid janky here. So I established where that is on the sheet. I'll put an overly large hole here with the hole saw. I'll slide it on down and set it over that stub, and then we'll lay out the furthest thing, the P-trap, in the slop sink, and go downhill appropriately and see if we can sneak in our Y at the floor. And so long as that's going to be all right, we know it'll be one straight shot from there through there, and everything else will just tie into it. And it will just be able to stick stuff to that plywood anywhere we need it to be. Everything should be on that plane, that surface of that plywood for the most part. We may have to block out for littler diameters against the bigger diameters and stuff, but I got a bunch of different hangers, all kinds of PVC, and we made a sketch, but I think you guys can picture what I'm talking about. Maybe we'll come back and look at the sketch in a minute. Okay, this is the plan. We're going to smash and remove this cast iron segment of the stack over there, and we're going to come in lower on that same stack, and we're going to come along this wall right here, up and up and up and up and up to the slop sink. So it's going to start at that point, the highest point, and downhill roll into the trap, which is, this will be 1.5 inches to here. Then we'll tee into the we'll sanitary tee in to the 2-inch stand tube and trap for the washing machine, which will continue to be 2 to this point, then bush up to 3. Meanwhile, 1.5 we'll go up and over to the kitchen sink, will come down and join us, then we'll go along in 3 here. 3, rather than going into the stack like this, it's cast iron right now, we'll saw it off and we'll roll down with a plastic, and we'll come right into the line here, and everything will go over and join the stack like that, and we'll get rid of this cast iron stuff here. We got the window to think about. I've showed the water supply for the sink and the water supply for the washer on the left hand side of it, but the way that things work out along this downhill run, certain components, to move left takes the run up by default, and to move right drags it downward, or vice versa. So you just want to be aware of the fact that you have to have flexibility here and remove variables, and I don't basically want to go across that window opening at all if I can help it. Unfortunately, 2 things: the water and the drain for the kitchen sink that I'm going to tie in cleanly to this stuff come over in a bay that goes right in front of the sink. It would have loved it on the left hand side of the right, so we'll have to turn and roll. I'll probably go, I don't know, to go left there's this heater hot water line. To go right is a nice clean opening, but it itself is completely in front of the window again, so we'd have to even go further right. And at that point, the dryer is close to where it's going to be. It's awfully far away for water to go to the washer. So I'll probably end up bearing left for that reason. Anyway, I've got the laser level set up here with the highest possible location that the P-trap can connect to the wall. I basically imagine that if I slid this up as far as it could possibly go there and left a little bit of room, how much would that add to the elevation of the current connection in the wall? And that was basically the highest point that I could have. And then I want it as far as left as possible. So it's a 2-foot wide sink. I went 1 foot off the edge of this sheet, which means that it'll be fully, the sheet will be completely behind the sink itself. So at 12 inches in, and at that elevation that I established, that there, now the laser line goes through there. And then I came over here and made sure that it was shine on the stack when I get over here to see what I had for an elevation there that I marked it there. That's where the laser is. So anyway, the distance here is about 18 feet. So divided by 4 is 4.5, which is how many? It's a 1/4 inch per foot. So that's 18 1/4 inches worth is 4.5 inches down. And so the center line of the leg of the Y that goes in to fall into this stack has to be no higher than this. It could certainly be lower. So as we add components that push us down here, I just wanted to be sure that if I brought over the component that I expect to use there, which is this, you basically don't want to run out of room moving downward. So if right now roughly there is where that lower mid center line is, I've got almost a foot of pipe, so I could go down quite a ways. And I really don't have the best practice. I don't want to be sitting on the floor. I want to be as far away from it as possible. So I want to be as high as I can be without being so far down that I'm into the floor, obviously. Anyway, these are all the checks that I'm going to do here, and it looks to me like I've got all the flexibility that I need. As I get farther away here, the lower that has to go, and at a certain point you have to take a different route, but that's not going to be us today. This kind of stuff here is just like It looks like Dr. Seuss. Any of this Dr. Seuss looking shit is just it's a klaxon in my ear when I see it. Red flag for sure. Whether you hear a red flag or you see it. Alright, we'll come back and look now after I've gotten a little farther. Okay, we've got our new connection with a shielded or banded Fernco or hubless connector here, and that's so that we can use it underground. It's protected against collapse and stuff in the central portion that's rubber, the unprotected portion. We had to run out to a special place to get that, not too far, but and now we're all back to PVC all the way up, and we hacked off the bell end of the cast iron here, and then slid the Fernco onto this PVC, and the PVC would sit down into the end of that Street 90 that goes into the ground, and then it would clear and tip over there, and we could align it, and then we can slide the Fernco up over the cast iron and tighten everything down. So that's where we left off last night, and just put a rag in this connection here, and now we're headed in this direction. And we want to make sure that we're going downhill 1/4 inch per foot or so. So I set up the laser level to be at the halfway point here, and you can see that as we move over here, we've moved down from halfway by about 3/4 of an inch or so, over 3 feet, which is 3/4 of an inch. And I was sure of that because I got this much constructed together. You can put the street, and this is something I'm going to go over in the video, but you can put the street 45 into the T or the Y here, and you can use the little lines that they give you. You know, like this has got, right there it is. It's hard to see here, but you know, you get a little tab that's at the perfect, you know, half plane here, and that can be aligned to the little mark. That's what all these are for, you know, on the hub itself. So I can glue this together, and I can clock it back and forth, spin it when I turn it in there, and be sure that that's perfectly aligned. And that's the way that I work, is I'll make a perfect component. That's the wrong way here, but we want to be up. But I'll put that in there and glue it perfectly clocked in alignment. And if we're going to bush down on one of the ends like we are here, I'll put this bushing in that goes from 3 to 2 inch, and I'll put him in to the end. And I'll build this component careful to align all that stuff. It's a little low, but you know, we'll glue that all up. That's something that doesn't need to be loose or glued, you know, in the middle of trying to glue a run. So I'm going to start building components that I'm, you know, aware that I want to make commitments to. Same with this elbow that goes to the P-trap for the washing machine. That can go onto this stick of 2 inch. Just do a good glue joint to it, and they can become one. Because it's not important clocking it or spinning it around the axis of this here. So you're going to start locking up variables in an orderly fashion. And the way that I did it here was I put this street 45 into the Y here and aligned, you know, the backbone of it. You can see there with the little tab there. Made sure he was glued in place. And then I believe I glued this street 45 into this Y and make sure that was clocked correctly, and let that set up. And then I just stuck that dry to this piece of pipe and put it in there kind of dry, not completely tightly, but I went up and down here and supported it. You can use anything. I used a box and rocks, and you may have a clamp turned around to push or something like that, but I went up until it was held at the elevation that I want as per the laser, and then I just measured from the face of this fitting to the face of this fitting. And I know that this is a nominal 3 inch sized pipe, so once I have the measurement, I just add 3 inches, because it's 1.5 inch engagement, 1.5 inch engagement on 3 inch pipe. They make it real easy. If it's 2 inch pipe, it's got 1 inch of engagement. Okay, so you just add the nominal diameter if you're looking, you know, 1/2 of the nominal diameter if you're interested in one of the engagements. Anyway, I figured out the leg here that I needed that would hold it at the elevation that I wanted. Then I took that down enough to glue in. I cut a piece appropriate in length. You know, I measured it and added 3 inches and cut it and glued it in here. And then I glued this all together quick, and then put some glue here and shoved up on it. And now I can be sure that this whole thing is locked up just where it's got to be, and it's finished. Now from here to the sink over there, or at least to the trap for the washing machine, is a couple long pieces of pipe with this Y and stuff in the middle of it to catch the sink drain. I'm going to glue, like I talked about, these things into one kind of super fitting, put that onto there as a primary, you know, the first glue up. And then I'm going to glue the bones, the long pieces of pipe, this one and that one there, when it's all laying on the floor, and I'm going to, somewhere, I'm going to try to find a spot that looks pretty much straight and level, and let that all glue up into one long section. So then I'm not getting the middle around this fitting when I'm trying to glue everything out here in space. falling down on me and creating a belly, which is common. If you glue it up and assemble it on the wall, all of these connections, especially when they're lubed up with glue and before it cures, have flexibility, and that's so you can get this 1 inch of fall per foot. If everything was so perfect that you couldn't get anything to be a little bit at an angle, and it would, these connections held everything at perfectly 90 degrees, the way that, they've been made, then you'd never get things to be able to fall. So there's flexibility and alignment there. Now, like I was saying, if you glue it all up hanging on the wall, that can work against you, and you can get a low spot where stuff always slows down and hangs out and screws it all up. So I'll do my best to create a long straight section on the floor where it's been supported so the glue will harden. Then we'll pick that long straight section made out of several end-to-end straight pieces. We'll put that up on the wall, and we'll go from here, which is pretty rigid now as far as being able to hang down. And I'll be able to go to, once I'm in, I'll be able to go to the other end and go up and down and make sure I'm at the right spot in the laser without having to babysit the middle and it collapsing on me. Now, if you have a framed wall and you can put a few cleats on the wall using a chalk line or a laser to be sure the cleats will support your pieces, well, then you can more accurately build it on a wall. But I'm dealing with shitty old falling down stone and not enough plywood here, so that's why we're going to work in this way. So you want to be just comfortable doing it in both ways. So we'll come back after these are up and have gone over to the point where we're at a trap for the washing machine, and maybe a little bit further than that. But everything's moving right along here. Pretty pleased. Even though we hit this snafu, I was able to button that up pretty quickly. Okay, I've moved the equipment over to get a sense of how things play out. I'm pretty pleased with all of it so far. I wanted to be, like this with the edge of the plywood, which is cool. Screwed the sink to the wall, which is nice. The top edge of the plywood is level, so it's off the floor a little, which is fine. It'll be something now, given, being level and having some thickness. I was telling Jay, this will be about as close as you can get with any of your equipment. There's kind of a big pit back there, but there's enough wood here to put some L brackets on and set a shelf across and set right onto the top surface of this, and know that that looks nice and tight, and then the shelf is level also. But then you've got all your stuff right here, your soap maybe for laundry machine and stack clean clothes or whatever. So I think everything's going to work out nice right there. I also choked up this end of our whole raw plumbing system. I want it to be as high as possible, but the benefit of that and the benefit of tucking the trap up, this is all 1.5 now. Tucking that all up nice and tight is, I think you can get a 5-gallon pail under it almost. Or anyway, you just maximize the room underneath it. And the washer for now is plugged into the ground fault circuit protected outlet with the sump pump. And then there's this outlet here, which Jay was saying he may just go down underneath there with a couple more conduit boxes and some conduit, whatever he so choose. I put this valve on the wall here for washer and dryer hot and cold. They don't sell these right to PEX yet, so I got one and I'll just sweat those into PEX there. It has a drop ear on the back because I wanted to attach it nice and rigid, but you do have to take the body of the valve off to tack those and then put the valve back together on it, but I'll sweat those little stub things in there. That is, the opposite of when dangling ass shutoffs dapping on the end of some random, PEX run. Same reason I don't like these valves in the middle of PEX, and it's just not, you can't, in my head, you can't treat as copper. You can't work with it like it's copper. Copper's more rigid, and you can count on it to be structural sort of and functional, whereas PEX, just got to approach a different way. I like all of my, elbows and T's may be in line, no problem, but valves, I want them always with a drop ear. Always, and attach them to something that controls the look of everything and the feel of it and stuff, and you don't get stuff from water hammer flapping around. So that's that. Why did I turn this on? Oh, so we hacked off the kitchen sink run that went over there, and I'm just roughed in by putting a elbow, where are we, up there, long radius here, and then we're going to go through 2 joist bays so that we can turn and run along this one here and then come straight down, and we'll go right into this, which will go right along there. But I wanted above the plane in the ceiling in here just as a best practice. There isn't going to be a lot of other stuff in here that isn't above the plane in the ceiling, so alternatively coming all the way down and turning and going underneath these joists here, if I did that on, the system is on this side of the beam, so if I dipped under the joist and fell, I'd have to go so far to get under the beam to turn and come down here. Then I'm in head space. It just would have been shitty and ugly. So these self-feed bits are so legit. I haven't got to push this at all You know, it screws itself right in. It was brand new. I mean, it's 65 bucks with tax. But on this setup here, I just went straight through 2 joists, 1, 2, overly large hole. That was the biggest one I could get. I might have liked to get closer to 3 inches. That was 2 9/16. But now I know that within the 2 big holes, even though they're basically in the same location on the joists, I can go downhill a little bit with this stick. But you can see that this stick has not only had to bend, you know, I'd only drilled those 2, so I've had to bend up and through there. And to do that, I had to use this big clamp to pull this hot water for the heaters tightly down to the beam so I could get over it as much as possible. And then I went in and ran into this other beam when I got up there, or excuse me, joist. Come on, Chaz, what are you trying to do here? This is the beam, these are joists. So then I had to pull it down to align to that hole, so I had 1 ratchet strap doing that, but it was still over to the right, because this end of it's over here to the left, so then I had to pull it this way, so I had to pull on this steel pipe, which it did a fair amount of bending before this moved over, and now we're aligned. And so since it's aligned, I can take a dead blow hammer, and I can tap on the end of her here, and over there you'll notice as we go through the hole, and we'll go here until I learn to hammer. Oh, then we're going to hit the bridging. And anyway, if I measured correctly, by the time we come over and engage with the elbow, there'll be enough room here to turn with a long radius and head down there. And then we'll go down the wall, button that up, make sure it works, and then we can rip that down a little later today. All right, next thing next. All right, stop for a little snack break. Still haven't fixed that smoke detector, sorry. I'll get to it. Maybe I should get a battery. Just about to go out and get a couple small things. I brought water over from right here. Can't run the flash. Anyway, these go over and go upstairs, so we're going to tee in to hot and cold right here. Go right across. Went right over this threshold. It's a couple of planks, so I actually had to drill through solid wood the entire way. I had to go out and get a 1-inch auger bit, like you'd have for putting in like a silcock. Anyway, so I picked a route for those, kept them off the outlet that's there that may move, and brought them down here and turned in. You know, cold's always on the right hand side, so since it was going to be the first to turn in, I put it nearest the outside wall of the building. So you want to think about what makes the most sense there. And then hot to here, hot and cold down to here, and those are 2 drop ears, and then brass nipples, and then shut-off valves here. This is just some water that's dripping from the sponges above after I tested this. But I ended up able to pin those to the plywood. I was pleased that the plywood worked out flush with the edge of the sink. I might have gone a bit farther with it, and I would have been able to hold those, but I just didn't have the understanding of where these were going to go. I toyed with the idea of going through the sink, but then if you ever need to take the sink away, equipment should be able to leave plumbing and come back without ever being entangled at all. Same with the rest of this hose. When you pull this type of fixture out, you don't want that big loop of hose to get tangled into the supply line, so you want to make sure of that. And you know, all the water hoses and drain for the washing machine, don't get those tangled when you install. You should be able to take the equipment away quite a ways and then put it back, and you want to have flexibility. So same with the gas supply here. You leave a leg in this to collect moisture, and then you can go to the side with your valve. And I just tied in here and got rid of that redundant switchback and everything else. After I put the pressure back on, I just sprayed all the joinery with Windex, which is like essentially soapy water, and see if it blows any bubbles. If it's not blowing any bubbles and I'm not smelling any natural gas, then we're no problem. Now you notice I had to squeeze the dryer back as far as I could while still passing the drain line with the dryer vent, which is why I use these telescoping square, like low profile vents. I had to buy 2 because there's normally just 2 pieces that slide past one another. I buy the one that Home Depot carries and the one that Lowe's carries, and because they're a little bit different, and each of them have 2 parts, one that fits over the other, because they're a little bit slightly different in size, you can actually telescope 1, 2, 3, 4, and the lower goes, as it goes up, it sleeves into it, and then it sleeves into this one, then it sleeves into this one, and it goes out, because we want our edges to be in line with the flow, and we want to try not to get any of our lint caught. We don't want to be blowing lint at the inside edge, you know, going in the wrong direction. And then we worked out the elevation there and just went straight across and out, and we just taped all the joints with a nice thick gooey tinfoil tape for ductwork. That's designed to be flexible without tearing immediately. You want to go with a good quality thick one, not the thin stuff. And only tape, no zip screws, because really you shouldn't be roughing that up, and the zip screws just stick into the line and catch lint again. And the whole game here is to keep from collecting a lot of lint and for it to go as quickly, in fact, effectively outside as possible. So that's essentially what we've achieved. All I got to do now is get a couple more. I got to get another bag of elbows and swing the kitchen sink supply in here and right into some T's there, and then all of that'll be connected. But then lastly, I saw that this water line runs over here for the water for the fridge. So I'm going to have to come up with some kind of a takeoff over here for the fridge water, I think. And then all of this can be ripped down. All of this janky jankness is all got to go. All of this copper past where these are take off, all that copper over there is trash. That could come all down out of there. All of this weird, I can't use my flash, but it's just a tangled cluster. All this loose shit is all going to come out of here, rip it all down, and that plywood off the wall, and it'll just look so much cleaner. Same over here. We're going to lose, you can't see it, but this big route that comes over from over there can completely go back all the way over there, and this whole stick that goes over this way, same one here, the white PEX goes to a push to connect there, and it's copper over through the wall. That T's in here that we'll just replace with splice only and get rid of that leg. All that stuff can come right completely out, saw up the copper, return it for scrap metal money, and then we'll probably come back and look when I've got the whole thing cleaned up and working perfectly and looking its best. Anyway, we're almost there. Okay, well, you guys have heard me bitch and piss and moan about it. I finally got a new phone. Pixel 6 Pro by Google. Just trying to give you a sense of living in this Victorian farmhouse. These are the servant stairs to the kitchen. Hey, this isn't the right lens. There it is. But let's check out that. We haven't gotten back to this laundry room. Well, they've been living in here, but we saw how that got cleaned up. And I just wanted to put a month or two on this now since we finished it. Wasn't sure what everybody saw. The hot gets real hot, so it's wiggled out a little bit, but in this I never ended up with anything to hold it, but everything's been working real well. Cut in the refrigerator, got the dryer vent out, got this all gas line and drains coming down this way. Everybody tucked back. I mean, this has still got my tools and stuff laid out on it from doing the project. We're over across the yard on this video series I'm going to cut together at some point pretty soon, but I wanted to look this over. Everything's working out real well and looking a lot sharper than it used to look. I can't help that it's a laundry room still in the basement, but certainly a lot better than before. Oh, we had the kitchen drain. I could do a little bit of foam around that. This has got like a 40 times zoom now. Oh my god, you guys, I can tell you all about stuff from so far away. We can see it though, so close. I didn't want that 100 times zoom from Samsung, I want to say. To hell with that. Never liked any of the Samsung phones that I'd had, and LG's not building phones or phones like the one I had anymore. Alright, thanks for watching. We'll see you.